Hello and welcome to another modelling video. This is Alan from the Wakona Man at YouTube with another modelling video. Today we'll be doing another 3D printing video. The series is still going and going strong, as I might add. It has sparked up some interest in 3D printing in the modelling community. And with my club, Mecha Workshop, that club's printers also online, so there'll be a lot of 3D printed models entering the Australian modelling community, which you should see around Facebook and YouTube. Some of those projects will also be posted on this channel, as well as a new method of treating those textured lines, which I covered in the Alphonse helmet video. So look out for that fairly shortly. It's a model from a different 3D printer. And today we're going to talk about the settings that you would set up to do a print. There's a lot of options regarding supports, fill, wall thicknesses, all that sort of thing. I did not quite even understand myself with the first few prints, and I've had some failed prints because the model disintegrated from being torn off its supports or not being strong enough, weak enough, whatever. So I've drafted up these little blocks and cylinders, and I've set them at different strengths and weaknesses, as well as different fills, and measured their weights, the amount of material they used, the time it took to print, to see what is an ideal thickness of a model to print, as well as how much fill in the way of your cost and time of printing it out, as well as how much material you consume. Now, a 3D printer is designed for many industries, hobbies, whatnot. Some people need a mechanical working part, such as a piece on an engine, a tool, a part for a lawnmower that might take a lot of damage. So you print it out of a certain plastic at a certain density, at a certain thickness. And you might just want to draft something to see what it looks in 3D in your hands very quickly, very cheaply, before you machine it or make a proper copy. So you'd print it out as weak and cheap, as light as possible, have a look at it, make alterations, throw it in the rubbish bin immediately. What we want as modelers is something that we can work with, sand, cut, drill, strong enough, and that you can hold it in your hands firmly enough to use manual tools, though is not too expensive. Sometimes we'll want a part of a model weighted to hold down the rest of it. Sometimes you want it lighter. And the best thing about the fill options is you're able to manipulate weight, as well as the thickness of the wall. You want something strong enough that it's not going to fall apart. Now, since the nozzle of the 3D printer prints in very fine layers along the Z-axis, it will have its structural weaknesses because it's not true solid plastic as a injected mold piece. Its Z-axis is where it's most likely going to split, especially if it's not printed absolutely correctly or the calibration is off. That could be strengthened with putties, glues and whatnot, but if the wall is thicker than the wall of an injected molded plastic model kit, it could be quite strong, if not stronger than a normal model kit. Something that could survive even a fall, which we're not ideally trying to design a model for that, but just the setting that's right, that's not wasting too much material, that's not taking too long to print, that it is okay to take on manual tools and machines. The next part of this video is going to be looking at the software of the Up Plus printer. Other brands and softwares are going to be very, very similar in its layout and settings. It might be called something similar, but generally they all have the same traits as how fast, how much coming out of the nozzle, thickness, fill, etc. Let's have a look. This is the Up printing or plotting page, and pressing OK would print it immediately. You've got a couple of bits of information, nozzle height, which printer to use. What's really important is the quality. You can go normal, fast or fine. They have all different advantages and disadvantages. Quite a thin model in ABS or especially PLA, fast would be ideal. Something quite detailed or something quite solid, you'll probably want to go for the normal. If you feel that your model's going to warp a lot, you might want to pause it at multiple times and have rafters on your model, unless you know for a fact that your printer can print in raftless, or it's not going to stick as effectively. We're going to click on preferences and see what else is there. On the preference page, it's easy to think of 3 global or major sections. We've got the Z resolution, which is a global control. We'll get to that. We've got the parts thickness, the fill, and the supports. Now, it's important to note, if you're going to be playing with all sorts of settings, you need to have the Z resolution set as fine as humanly possible. This overrides everything. So if we've got it at 35mm blobs being printed, and you want to print a very thin membrane wall or area, generally this is going to override it and print it out thicker, ignoring your other general settings. If you want everything to be just overall thick and you're not worried about detail, you're just printing out blocks or balls or whatever, then chuck that on and it's probably going to print a bit faster, a bit stronger. But overall, when messing with most settings or quite a detailed model, 2 micron or 0.2mm is your best bet. Now, for part thickness, we're going to play with this a lot during this video. We've got multiple layers, from 2 layers to 6 layers, which I assume would be 2 microns or 2 layers of plastic being extruded to 6 layers. I'll be checking out which one is stronger and which one is weaker through prints of test little squares, seeing their weight, squeezing them, seeing which one's stronger, and maybe some larger ones and put them through some sort of durability test. They can be manipulated from this drop down bar. To the right, which is slightly clipped, is fill. We've got everything from what looks to be quite a solid hexagon looking, or not hexagon, crisscross pattern to something that's quite light. I'm labeling them as 25, 50, 75 and 100% thickness or fill. We've got shell and surface. It's the fill's fairly important if you're printing out a block. I'm going to see how it affects the weight, durability, and the general detail of the printing if it covers a lot of the top Z-axis area. Below support, where the camera is mostly fixated on, is looking at rafters and support pieces. We're going to cover that in a future video, so for now it's going to be ignored. Now, just as a bit of a case study, I'm looking at this piece of a Gundam kit and a piece of a military kit. Now, the majority of the piece is about 1mm to 1.2mm thick, out of absolute solid plastic. It does have a bit of flex, though in certain areas it gets a bit thicker as support. Around the edges it's got a lip, and other areas it's just generally thicker, which is injection molding plastic. The military piece on the sides is even thinner, but it's got areas where it actually gets quite significantly thick. This is a structural piece. Now, we're at a running disadvantage. Injection molded plastic or styrene is molded using heat in a single piece, so it's fairly consistent and strong in all areas. 3D printers or printed pieces along the Z-axis is all these bonded or blobs of lines of plastic on top of each other. So where those joins are between each layer, a lot like laminate or particle board, its weaknesses lie there, as well as other areas where it gets quite thin. So I'm assuming that 3D printed piece needs to be significantly thicker than a Gundam model piece or a military piece, even though I can't quite design those little support areas, and I'm wondering if the fill is strong enough to make the model fairly solid and take that brunt as extra strength. Now, here is all the prints. The first section is going to be fills and different shapes. Just to make it very, very quick, I did a 3x3 by 4 centimeter print. Now a larger object will be obviously a lot weaker when it's thinner, so a larger object you generally want to print thicker and heavier. Smaller objects not so, because where there's corners or round bits is where the majority of the structural strength of the model is. So we could see with the first piece, it is 2 layers at 50% fill. I'm doing everything at 50% fill for this section. So you can see the fill inside. And the reason why the fill is important is it's scaffolding to print the top piece, or otherwise the top piece will be printing over nothing and it will sag like hell. Now because the fill isn't too consistent and the wall is really thin, we've got all these holes. So at some parts it's going to be wafer thin, other parts will be full thickness. So that's not going to be very strong on the X and Y axis, but the Z axis, which should normally be the weakest, is in this case the strongest. Now the support's also wafer thin. When you move it around your fingers it buckles, so that's not going to give you any strength, and when you squeeze it, it sort of flexes a bit, but we'll look at a bigger piece. Now as the layers continue, 3 layers, 4 layers, the speed is fairly consistent, but the grams slowly rise in a tiny amount. Me thinking that if such little material is used to make thicker walls, that the part is a lot stronger. When you squeeze the 6-layer model, it does not flex anywhere near as much. And it's only literally using for such a small piece an extra 0.4 grams. Now round pieces are a different story. They're consistently strong all the way around, so the fill doesn't matter, and this is the smallest or the less amount of layers. So with your flat surfaces, wall surfaces, boxy surfaces, you want something a tad thicker. Round surfaces, not as much. You can still do it if you want, though due to how thin the layers are and how little support is, there is some major holes. So obviously the top bit is still going to be quite weak. So for a round bit, you probably want to go for 4 layers instead of 2 layers, as 4 layers over here. Some bits are a bit thin, you can see through, but it covers consistently. At 6 layers, it is completely solid, but slightly warps. If I did a slower print, because I printed everything in fast, it would not warp whatsoever. So thicknesses, I reckon with model making, go for as thick as humanly possible, and just a medium fill between 50 or 75%. A larger piece, I'd probably be more inclined to go 75%, but it's not going to waste or use up that much extra material, and it will not affect the weight that much. Fill would be the best way to alter the weight, but not so much the strength, though the support of giving a really strong top, definitely. The sides, not so much. Now fill is a completely different standard. All of these are 2 layers. We're going to have a look at this. 2 layers, minimal fill, very, very fragile. Definitely flexes heaps under my fingers, lots of holes. Tools will definitely tear through it, and you'll have all sorts of problems if you want to cut it, machine it, stick it together. A low fill and low layers, definitely bad news. As you increase the layers, 75%, it is very solid. Obviously as the layers get more dense, even though they're wafer thin, they're really hard to damage with my finger. Where with this, I have actually broken it with just the pressure of my finger. It's all messed up in there. 100% fill is significant heavy, and I reckon that this would take a bashing of a hammer. That is solid. It is double the weight, from 3.6 grams at 25% to 6.4 grams. So it's double the amount of material and almost double the amount of time printing. If you wanted something to weigh down the very bottom, or you want something just critically strong, full fill is a good idea. Minimal fill, very bad idea, especially at minimum layers. Medium fill, 75% seems to be pretty good. 50% probably for smaller parts, 75% for larger parts. Obviously the larger parts are going to be plenty more expensive. Now I've done some big prints to prove a point. The larger piece, this is about 4 centimeters by 6 centimeters, and that's the fill. The fill is also 50%, but it spreads out more. Now look how much that flexes, and that's just finger strength. Full hand strength, even worse. Don't think it can take any weights. The Z-axis is incredibly weak. The X and Y axis also flexes, very weak. And a bit of the fill actually fell out when I cut it. And this is how thin, wafer thin. Breaks into nothing. And if I stick my finger in there, if I was to machine it, pull it apart, very weak, not reliable whatsoever. What it's good for is if you want to make a hollow model and remove the fill, a weak fill is fairly ideal, as we could cover that with plastic, putty, whatever, if it is actually important. But for modelling, not ideal whatsoever. This is 5 layers thick, 75% fill. Now, in the way of grams, it uses about 30% more material, and it takes about 1/3 longer to print. And this is the same thing, and it is solid as hell. I haven't cut it open because I'm going to use it for a purpose, but I'm going to take it outside and smash it against some concrete and see what happens. This will not survive as much. This, pretty damn solid. So right now I'm smashing the thicker, stronger piece against concrete, full force using my hand, and then bashing it with a spanner. The camera angle may betray you, but I'm pulling it quite big and back and giving it some decent blows. The damage is minimal, but you would not ever sustain this sort of damage on a model kit. More or less the same treatment on the weaker model. You can see that the damage is substantially more, and it just doesn't take the impact. Now, a lot of you may be wondering what was the point of the activity, roughly where the default settings should be strong enough, somewhere in the middle of the road, but it's going to get more complicated when we look at entire prints opposed to prints when a model is sliced up or many in different parts, as well as fine parts and parts with supports and rafters. Now, I've done a couple of models. I've got this 3D printed component part, and there is all sorts of damage. As I've tried removing the rafter, the actual model started disintegrating and ripping it to pieces, exposing the center. The walls were quite weak. The support is very strong. The support etched to the material far too strongly and started tearing it up. Now if we get a little damage like that, and if the model is thick enough, we can use putty, glues, whatever. That's not too much of a problem. Now I tried printing out the chassis, 72nd scale tank. Now as I started removing the supports, because this is in one piece, there's detail everywhere. Some of the detail is wafer thin plastic. Now, as that started getting removed, which was actually really thickly and really baked on, the supports were printed thickly, close together, and as I started ripping it off, because the supports of this style of 3D printer meant to be easy rip off in ABS, it started ripping the actual detail of the model up, and started exposing detail right there into the inside of the model. So that part obviously printed very, very thin. So I've got the actual model getting damaged. I've got the supports removing the model getting damaged. The model did not print out very strong or sturdy. I push down on the vents at the back. It's very weak. I can actually feel the springiness of the fill. So this this model was a complete failure, as well as this 3D printer part. And I believe if the supports were printed thin enough and the model itself thick enough, the detail won't rip off. Another way that I could have prevented it is if I didn't download the models from Thingaverse and I actually drew them myself and drew them in many parts like a model kit, printed them all out individually, as little supports as possible, glued it together, treated it, painted it, it would be far more successful. A lot of work, but less detailed, ripped up. Now, remember with my Alphonse helmet, this is another helmet, and there's all this crazy, very thin plastic around the model. And this is the support. This is the majority or the weight of this model is printed in mid-air. And it constructs these scaffolds and prints on top of them. Now, if the model's quite heavy, the printer is printing very fast, not time for the plastic to set and harden, it's going to collapse and fall in a mess of spaghetti. When we're printing something more detailed, bigger, and in mid-air, a slower printing setting will be far more appropriate than fast. Something very simplistic like these blocks I'm making, fast is fine. The thicker the model, the more chances of it warping. The thinner, less chances of warping. The thinner the model, more likely of breakage. The thicker the model, less breakage. And this is where I'm in a situation. When we're printing things with support, a thicker model at a slower print would probably most likely be likely with still chances of failure depending on how the model was designed. Now, next time I'm going to do this video, I'm going to print off a heap of parts. They're going to be like spheres, upside down triangles, upside down cups. They're going to be models that are going to require supports, and that the supports will have to be removed quickly using conventional modelling methods. I'm going to print some parts really thin with thick supports. I'm going to print some models with thin supports, thick parts, see what cleans up a lot better, and how to get a sphere. Now, if I was to actually print a sphere, I'll print it in two parts, the flat parts down, glue it together. Though for the point of this exercise, we're just going to see how supports come out, and we're going to see how to clean them up and what settings would be best to have models with supports if you wanted to get things off Thingaverse. Thank you very much for watching. I hope some of the rambling tests and information in this video was useful. By all means, this is not a tutorial. These are just my sheer experiments. I'm still playing with the 3D printer. I'm still new to 3D printing. I've only had this for about 4 months now. I'm up to my second reel of plastic, and yet I have produced successful prints and successful models that are finished products. Still learning, and I'm willing to bring you all along for the ride. Leave any comments if you got any ideas. I'm very happy how the experiment went. I might have used up a bit of plastic, but I've got a really strong idea about different settings for far more successful prints. I'm still an absolute amateur, and I absolutely admit I have been avoiding supports like crazy since I've done this tank and some more ambitious stuff when I was playing with the end of the ABS roll, the first of my PLA roll. But now I'm going to give it another go, and I'm going to see if I can get better results, because there are some models of Thingaverse I would like to have a go at, and I don't want to tempt them until I've got a far better understanding. Thank you very much for watching, and as always, until next time, I'm going to continue the 3D printing series when time allows for it. The Gunpla Builders World Cup entry will have a lot of 3D printing, as well as some models, some models no, and hell, even basic bases and dioramas. This thing will be working quite often, and some of the stuff we're producing for the club, I've actually got a Mecha Musume model, which was covered in the workbench video of the 3D printer. That would have been a few weeks ago. And I've been given a Star Destroyer from Star Wars in parts. Very cute tiny model, and it's coming together beautifully. When that model comes out, it's going to be a video on removing texture like the Alphonse helmets, but using a much smarter, superior method, and not just mucking around and experimenting with different thinners and acetones and putties and stuff. So that model is going to be made a lot quicker. Catch you guys later.